conics. All right, in the last section, if you remember, we took a nice little conic section, centered at the origin, and we just translated it. We didn't change the orientation of the major and minor axes. They stayed where they were. In this one, we're going to do something a little bit different with it. We're still going to translate it. But we're also going to allow the thing to be rotated. All right, there's our original X and Y axes. If you notice, here is my major axis, and here is my minor axis. Okay, what we would like to do, obviously, and I'm going to designate this as X, capital X, and capital Y. These would be lowercase x and y. What we would like to do would be to have these lie along here. So what we do to take care of this is we basically rotate our original coordinate axes, whatever this angle needed, to make our original axis lie along this axis. And that's the whole idea behind this. And we can also translate these things too, in addition to what we're doing, which is the shifted part of this. All right, so if X and Y is a point on a conic, section, we're going to find the location of that point on the rotated axis. Okay, so capital X is the rotated x-axis, and that is equal, and this would be the coordinate, the x-coordinate on the rotated axis. That will be x, which is our original one, times the cosine of the angle we're rotating through, plus y sine of the angle. And the y-coordinate of that point is y cosine of the angle minus x sine of the angle. So if you're given a point in the original Cartesian coordinate system that we're used to doing, that's on the conic section, but it does not lie, it's been rotated, then you can find the x and y coordinates in the rotated section using these two equations. Conversely, if we know these, we can go back to the original ones. Okay, where x is equal to, this is the lowercase x, this is the coordinate axes we're used to dealing with. It's going to equal x coordinate in the rotated one, cosine of the angle, minus the y coordinate of the rotated one, sine of the angle. And the y coordinate is the rotated x coordinate, sine of the angle, plus the rotated y coordinate times the cosine of the angle. All four of these equations are going to be very, very important in what we're going to do next. Okay, let's work a couple of examples. This one, your instructions are to find the rotated xy coordinates for point 1, 1, where the angle of rotation is 45 degrees. So what we do is we come back in and we take a look at our original things I gave you, where the rotated x-coordinate is x cosine of the angle minus y, should be lowercase y, sine of the angle. And the rotated y is going to be y cosine the theta of your angle minus x times the sine of your angle. All right, so now what we do is we plug back in. This is little x, little y. So my capital X is going to equal to 1 times cosine of 45 minus 1 times the sine of 45. And my rotated y is going to equal to 1 times cosine of 45 minus 1 times the sine of 45. Now we come back in, the cosine of 45 degrees and the sine of 45 degrees are both square root of 2 over 2. So x is going to be equal to square root of 2 over 2 minus square root of 2. Should be a plus. And this should be minus, that's a plus. Plus the square root of 2 over 2. That gets me 2 square roots of 2 over 2, which is the square root of 2. And then my y-coordinate is going to equal to 1 times the square root of 2 over 2 minus the square root of 2 over 2, which is 0. So my x, my rotated x and y coordinates now are going to be square root of 2 and 0. And that's how you do that. Okay, next one takes a little bit of algebra, but it's not all that hard. In this example, I want to find the equation in x and y, in other words, in rotated coordinates. This is really the whole point of going through all this mess, is to take the original one and plug them back in. So the equation we got is x squared minus 3y squared equals 4, and our angle of rotation is going to be 60 degrees. So what I do is I'm going to substitute in for x and for y. If you go back up, you remember lowercase x going to equal to my rotated x cosine of my angle minus my rotated y times the sine of the angle. And my little y, or my original y, is going to be x sine of the angle plus y cosine of the angle. Now we do is we substitute these in for x and for y. So I'm going to have capital X cosine of my angle, which is 60 degrees, minus rotated y times the sine of 60 degrees. Square that minus 3 times the square of this guy, so it's going to be my rotated x sine of 60
plus my rotated y times cosine of 60 squared, and all that is going to equal to 4. So now I come in and I square this thing, and what I'm going to no, actually before I do that, I'm going to find these. Cosine of 60 degrees is 1/2. I'm going to have 1/2 x. This is the cosine of 60 minus the sine of 60 degrees is the square root of 3 over 2 y squared minus 3 times sine of 60, we just found it, and the square root of 3 over 2x plus 1/2 y squared. Now I'm going to expand these guys right here. The first thing I do is square this term. This will give me x squared over 4 minus. Now I'm going to have 2 times the product of this. So I'm going to have 2 square root of 3 over 4 times x and y. And then I square this guy. That will give me plus 3/4 y squared. So that's this thing expanded. Minus 3 times, and then I expand this thing. This will give me 3 x squared over 4 plus 2 times these, 2 square roots of 3 over 4 x y plus, and the square of that, y squared over 4 equals 4. This looks like a lot of work. It's not particularly, you just have to keep track of what you're doing. So now what I'm going to do is distribute this thing right here. So I'm going to have x squared over 4 minus 2 square root of 3. These cancel out. So I'm going to have square root of 3 x y over 2. I'm going to simplify that. Plus 3 y squared minus. Now I multiply everything in here by 3. So this gives me 9 x squared over 4 minus 6 square roots of 3. Oh, if I do that, I'm going to simplify this too. It's going to make things a little bit easier. So that will give me 3 square roots of 3 over 2 x y minus 3 y squared over 4 equals 4. Now I collect all of my like terms. So I've got x squared over 4 right here minus 9 x squared over 4. That will give me a negative 8 x squared over 4. I've done those. Now I'm going to collect my xy terms. So I've got a negative square root of 3x over 2. And I'm going to subtract 3 square root of 3xy over 2. So that will give me negative 4 square roots of 3xy over 2. As you can see, that will end up giving me a 2. And now I collect my y squared terms. So I've got 3/4 minus 3/4. So that gives me 0 y squared equals equals 4. Okay, so the last thing I want to do now is I've collected and combined all my like terms. I'm going to simplify these, so I'm going to end up with a negative 2 x squared minus 2 square root of 3 x equals 4. And I notice I've got a negative 2 in all of these. I'm going to go ahead and divide it out of everything. That's going to end up with x squared minus plus, and divided by negative, square root of 3 x y equals negative 2. And that is the rotated equation.